This is chapter 8, section 8.1, techniques of integration. So let's see first what techniques is. Techniques, when we say techniques, we basically mean tricks. Now, tricks is a complicated word because we don't talk about tricks in math. However, when we say tricks, we mean what is the algebra that I need to apply to get out of a situation. So how am I going to envision the algebra that I need? Well, only experience will help you now. And experience means how many hundreds of hours have you studied. If you have not studied much, then you probably won't be able to solve the problems because there is no rules now. 8.1, there is no rules. The UGU that we had been using is no good. It's not going to work. So here are some kinds of techniques we use. Conjugate. We use the conjugate a lot. You know what conjugate is. You saw this in 10th grade in high school, and you may have seen it again if you took college algebra. Long division, again, you saw this in high school and college algebra. Long division may help you get out of a situation. And the other kind of technique is to add and subtract the same thing. It's not just anything. You have to think, what am I going to add and subtract? Because if you add and subtract, you basically don't change anything. But the sheer fact that you added and subtracted something to the numerator then allows you to rearrange that and get out of trouble. Let me give you some examples real quick. Look at this integral. If you call this u, the gu is not that, so ugu won't work. So how do you get out of this? Well, look at the solution. In red, I added e to the x and I subtracted e to the x. However, what this is going to allow me is to break this one integral into two. Cover here, what's that? That's integral dx, because this piece is just number one. Look at this now. Well, this is simply another integral. So that's what I mean by add and subtract. Look at this integral. U will never give that du. So what do? Look at the solution. Subtract and add. You can add and subtract, subtract and add. I subtracted first to emphasize that. If you look now, this is not number one yet, but you know how to factor this difference of perfect squares. And once you factor this, you're going to cancel out x minus 1 and you're out of trouble. And look at that. That's the second integral. So this is coming up in video number 2. So let's look what problems we're going to study. You must study 5 to 46, and it's not just solving a few. You must solve all, because every problem is a different trick. If you learned a trick on a few problems, there is more tricks on the other problems. So every problem presents a different scenario. And then 57 to 72, same idea. Example ABC, page 516. Look at these three examples. The denominator is all the same. The numerator is 4, 4, 4. However, just 4, 4x and 4x squared. For this integral here, there is no UGU that can help you. So what do? Well, you might say, all right, I'll move this 4 out. Well, then you get to this. It's still good, but and now what? UGU won't do it. So let's see what's going to happen to this example A. Here's A. Move the 4 out, you get that 1 and this. Now, where you go from here? Well, you should be able to recognize the integral. Here is the integral you need to recognize. Okay, it's x squared plus 3 squared dx. This is a variable. This is a constant. Squared is squared, and the plus sign. This is a trig integral from our integral sheet. You must be able to recognize this integral, and you look up the sheet, and here is the solution. So your job is really to find the u and to find the a, because you need to plug the a, plug the a, and plug the u. Well, who is u? U is the base. It's not x squared, it's just the base, which is x. And a is the base, which is 3. So, this idea of base you learn in algebra, okay? Especially when you do ellipses and areas of ellipses, volumes of ellipses, you have bases there. So, you have x as a base, 3 as a base. So, the x is u, and the a is 3. So you put the 3, put the 3, put the x, and there's the solution. And that's it. B. Now we have an x here. So if I call this piece u, here it is, u x squared plus 9. Well, the gu is 2x, but I have 4x. Well, the solution here is to break 4x as 2 times 2x. Now, if you do this, 2 outside times 2x, you're going to see that you got your du, 2x dx, 2x dx. Therefore, the solution is going to be 2 log natural of absolute u. Because we got 2 gu over u, this is log natural. So we got back to log natural plus c. Absolute, but you don't need the absolute because x squared is always positive, plus 9 is always positive. Therefore, you can just put a parenthesis. And this is the solution. 2 log natural of x squared plus 9 plus c. That's how you deal with the case B. But now you have x squared. So here you got x squared, and here you got x squared again. This should ring a bell from 10th grade and from Algebra 2. This is long division. So you know long division. So you take 4x squared and you divide by x squared plus 9. Proceed on the steps, you get a number 4. And then the remainder is minus 36 divided by the dividend, which gives this piece here. Well, so what have I accomplished? Well, with long division, I broke one integral into 2. Here are the 2 integrals. So now we just show them 4, which is this 4 integral dx. The minus sign is because the remainder is minus 36. Outside, because I brought the 36 outside, I got this. And this is our trig integral again, the arctan with u equals x and a equals 3. You plug, and the final answer is here. Note that the 12 is because the 36 divided by 3 goes here. And here's the answer. So this was a peek preview into 8.1. In video number 2, we're going to see several problems, very specific ones. There will be solutions posted on Schoology. However, if you don't practice all the problems, you're not going to see all the tricks that the book gives you. Okay? Because every problem gives you a new trick. So make sure you do cover these problems and review the book examples and watch video number 2.